Welcome, welcome, welcome to Miss Lisa's YouTube channel where we talk about science and math. This is physics, and it is a class designed primarily for homeschoolers. But if you like the way I explain things, then feel free to join. We are going through this book. It is Merrill Physics. I had to have a bunch of different books. It's an old book. That's why I picked it, because it's cheap. You can get it used for cheap, and it's a good book. It's just fine. Anyway, so I am changing a little bit the way I do things. Instead of teach a little bit, show you the math, teach it a little bit, show you the math in this format, I'm going to do it like how I do my math classes. And if you've had me for Algebra 1 or Algebra 2, you know I do calculator videos where instead of looking at me, you just look at the calculator up close. And I'm going to do that for physics. So this teaching video will probably be pretty short because the main thing you do in physics is math. Physics is a word problem class. If you like word problems, physics is the right place for you. So instead of looking at me, which, you know, nobody needs to look at me, you'll be looking at the calculator and looking at the math. So the second video will probably be the more important one. But the concepts are important too. And if you're ever having problems with the concepts of physics, there's a really good book I'd like to recommend. Excuse me, I need some coffee. Yeah, it's Conceptual Physics by Dr. Paul Hewitt. And he's just really good about explaining the concepts. Now, this class is more college prep, where it is preparing you for the math of physics in college more, where his book is more about the ideas, and he's like, you'll learn the math later in college. So, but it's a very good book, and I would recommend reading it in addition to this one, but not required. This one's fine, but it's just a really good concepts book. And you know that I'm a geek because I have a favorite physics textbook author, and it's him. All right, so what we're talking about in chapter 4 is acceleration. Now, what is acceleration? You're like, I know what that is. Acceleration in physics is speeding up, slowing down, or changing directions. Now, the speeding up you knew, but the slowing down and changing directions, let's talk about it. When you're slowing down physics, hold on, I need some more water. I've talked so much today. Excuse me. I might have to start over. I might have to start over tomorrow if I can't stop coughing. In physics, when you're slowing down, it is called negative acceleration. So it's just fancy for slowing down. Now, what about changing directions? If you know how to drive, you might have noticed this one before. Or if you've ever been driving, and here in the Atlanta area, we have interstates. And to get on them, sometimes you go around a circle. Like you start off to get on the interstate, actually going in the opposite direction. And then it turns you around, and then you're going the right direction. And when you're going around those things, you want to keep your speed up because people are going to be flying on that interstate, and you're going to have to merge in. So those of you who drive, you will notice that even if your speed is staying the same, as you go around a curve, you give it more gas. And it's because that's why is that a turning is actually an acceleration. So speeding up, slowing down, or changing directions. You're going to be reading chapter 4, and we'll be looking through the math here. So there's two different ways to think about acceleration. You can think about average acceleration, how much will you take your total amount you sped up divided by the total amount of time, or you can do instantaneous acceleration, which is how much you were accelerating at that instant. So you'll be able to see different graphs with that. If you have velocity, or you can think of velocity as speed on like the y-axis, and you have time on the x-axis, and you graph velocity versus time, the acceleration is the slope of that line. A lot of times acceleration is not constant, and so the line would not be constant, and so then you do an average acceleration. but you can find instantaneous acceleration at any point, which would be the slope of that line. Now, there are a few problems we're going to do with velocity or speed. And when we do that, it's usually the average acceleration or the average speed. So a lot of times we have to consider that in our formula. You're going to, hopefully, if you've got the equipment for it, you're going to be doing a lab where it's a constant speed lab where you can measure constant speed. I used to have this little truck. And I got it at KB Toys. And anybody who knows when KB Toys went out of business, you know it was a long time ago. But I taught public school, and I had this little battery-powered truck. And you put a little battery in it, and you flip the switch on the bottom to turn it on, and it would do constant speed. It did not speed up, slow down, or change directions. $4 KB Toys, the greatest thing. One of my last years teaching public school when I taught before, I'm back in public school now, someone stole my truck. Those bad kids stealing my truck. Someone stole my coat too. I had a LL Bean coat and someone stole it too. So frustrating. You go work at a school, you don't expect your stuff to get stolen. But one of the things that really bothered me was that $4 truck, because it's so hard to find a toy that's constant speed. They're pull back and go, which means they accelerate, or they're those ones that are made to bounce off the walls and they always are turning, so they're accelerating if they're turning. But this little truck just went straight in a line. It was beautiful. The public school I teach at now has a bunch of them that they bought from a physics supplier. I haven't found a physics supplier that has constant speed cars, but they're these cute little dune buggies. They're so cute. But anyway, if you have a constant speed toy, then you can do this lab and make the graph. Last year when I taught physics and physical science to homeschoolers, we used an RC car, remote control car, that one of the boys got at Walmart. And it worked great. Because it was big, it wasn't completely constant speed because it had to come up to speed, you know, because it was heavy. It took a little bit of time. So we did it on my driveway for our labs, and we would start it before it got to the start line so it could come up to constant speed, and then we were able to do it, and we got great graphs. So I encourage you to do the lab, see what you can think of outside the box to see if you can have a toy, because it's a good training for making these graphs. There's a big part of physics in graphing the data, and this is a good lab for doing that. So I hope you can do it. If not, you know, life's life, but hopefully you can find something to do the constant speed car with. The homework will be in the description. So displacement is the distance, speed equals distance over time. And when I very first started teaching, I came in the middle of the year, and I had this one class that was just really rough. I mean, these kids were tough. And I asked them, what's the way we can remember speed equals distance over time? And one of the kids on the front row said, dead science teacher. And I was like, oh, this is going to be harder than I thought. Later, that whole class wore red shirts. And I was like, why didn't I get the memo that we're wearing red shirts today? And they said, oh no, we're a special group. We are the most at-risk kids in the school. I was like, that would have been nice for them to have told me that, but they didn't. But then I sort of watched those kids knowing that they were at risk, and you know, all of them dropped out of school but one. Only one made it to graduation. So it was sad. The program didn't work, and I wish we could have reached them. You know, I wish those kids could have had success, more than just one of them. Because I mean, it was a big group. It was 30 kids, and they did not make it. So you guys, do your work, stay in school, and you can make it with education. Okay, so now if you're graphing position on one side and time on the other, and acceleration is constant, the slope is velocity. So, if velocity is constant, the line is straight. So you can look at those graphs in your book, and they make pretty good sense. All right, see if there's any more ideas that we need to talk about. One thing that can cause acceleration is gravity. Newton with his apple on his head. And the acceleration due to gravity is a constant. It's 9.8 meters per second squared. So when something is falling, it gets faster and faster and faster until it reaches something called terminal velocity, which means it's not going to speed up anymore because of air resistance. So the thing has always been about if you had a penny and you threw it off the Empire State Building, would it become like a bullet and kill someone? No, because the air resistance would slow it because pennies are so light. And it would hurt if it hit somebody and you shouldn't do it. It'd be like cut their skin, but it wouldn't even penetrate their skull. So, and it's because eventually you get air resistance, and even people who have fallen out of planes and stuff, some of them have lived, believe it or not, because they have reached that terminal velocity. And they say that if you do fall from a big height, that you can actually sometimes fall smart, where you try to like spread out and make yourself have more air resistance, and also that you can kind of steer yourself in the air, and you can try to find some place to land where you won't stop suddenly, but your landing would be over time. So like people have hit trees and gone through the trees, and as they're break branches, they've landed. There was a guy whose sister, the guy went to church with us, and his sister lived through a skydiving accident where her chute didn't open because she hit a barn at the top and was able to roll down the roof and land. And like she was okay, like maybe a broken bone or something, but she lived after falling out of a plane and her parachute not opening. So, and then I've read where people have fallen in freshly plowed fields, like commercially plowed, where they go really deep with those machines, and the dirt went toop, and they lived. So anyway, terminal velocity, meaning that you're not going to keep accelerating. So just little safety things. I hope I never find myself falling out of a plane, but if I do, maybe I'll be clever about where I land. Don't aim for the parking lot. You're not going to make it. All right. Let's see. So we're talking about acceleration due to gravity, and it is, you will see how that is fixed into the math problems. We'll be doing the math problems in the second video. And we're also going to talk about physics, as I said earlier, is a class of word problems. Yay! Everybody loves word problems and fractions, right? It's word problems and fractions, it's both. But we're going to talk about how you approach them. And once you learn how to approach a physics problem, they're really easy. You just identify the knowns and unknowns. You list them. Then you find the formula that goes with those things. You plug them in and do the math. And you use your calculator. So the main thing is just identifying everything so you know what you've got. Put it into the right formula. Let your calculator do the math for you. And you've got the right answer. So I remember when I finally figured that out and thought, physics is easy. You just got to know the formulas, and then the math is always the same. You know, it's not that hard. It's just knowing which math to do. All right, so come back for part two. Part two will be, you won't be looking at me anymore. Yay! You'll be looking at the calculator, and we'll go through the math, and the homework will be in the description. So like, subscribe, share. I still have a goal of my 1,000 subscribers, and come back next time because science is great.